Hello class, these are our notes for Algebra 1. We are looking at section 7-8 today. We are rewriting quadratic expressions in factored form. So we're just furthering our ability to factor right now. So sometimes expressions in standard form don't have a linear term. So if we think about x squared plus bx plus c, we have our quadratic term, we have our linear term, and we have our constant term. So the quadratic term is called that because it's the one that's actually squared. The linear term is the middle one, bx, because if I graphed y equals bx, I would get a line. And the constant term is because it's just a constant, I have no variable. So we're looking today at factoring quadratics that don't have a linear term, so they're missing the middle term. So we're going to take x squared minus 9 as an example. We can think of it as x squared plus 0x minus 9. We need to find two numbers that multiply to make negative 9 and add to make 0. The factored form, so let's think about this. Two things that multiply to make negative 9 but add to make 0. Well, that's going to be a negative 3 and a positive 3. Those multiply to make negative 9, but they add to make 0. So essentially we're looking at the positive and negative square root of 9. So the factored form is going to be x minus 3 times x plus 3. So in general, a quadratic expression that is a difference of squares has the form a squared minus b squared. And this is going to factor as a plus b times a minus b. And those can be reversed. It doesn't matter which order those factors are in. So can we rewrite x squared plus 9 in factored form? So let's think about how this is an x squared plus 0x plus 9. So things I could multiply and make a positive 9 are 3 times 3, negative 3 times negative 3. Let's see, 9 times 1, and negative 9 times negative 1. So which of these add to make 0? So 3 plus 3 adds to make 6, negative 3 and negative 3 adds to make negative 6, 9 and 1 would add to make 10, negative 9 and negative 1 would add to make negative 10. None of them makes a 0. So no, we cannot rewrite that. So if I have a squared plus b squared, it is not factorable. I've got to have that minus sign. So we're going to go through and we're going to do some of this factoring. So really we're looking for taking the square root of both x squared and 9. Or maybe thinking about what squares to give you 9. This is like an x squared minus 3 squared. So I have an x minus 3 and an x plus 3. And again, you could reverse those factors. I'm going to go back and forth with my negatives or positives to kind of drive that point home. The next one, 4x squared, well, that's like having a 2x and squaring it and a 3 and squaring it. So I'm going to write it as 2x plus 3 times 2x minus 3. 64x squared minus 16. So what I noticed right away is both of these factors are positive. I can divide 16 from both of them. So first I'm going to factor out a greatest common factor, and then I have 4x squared minus 1. So 64 divided by 16 is 4, 16 divided by 16 is 1, and then I can keep factoring because 4x squared is the quantity 2x squared minus 1 squared. So this is going to be 16 times 2x plus 1 times 2x minus 1. For my last problem, my x is being squared, and then 81y squared is really the quantity 9y squared. So I have x minus 9y times the quantity x plus 9y. So lots of new factoring today. Everything's going to be mixed together, which is going to make it a little bit more difficult for you. But I think these really stand out because we do not have an x term. We are missing the linear term. And so I have an a squared minus b squared. We're really looking for that form. So as always, class, if you have questions, please make sure you ask.